Grantnowski.
I'm Alexis Nocky.
And we're here to teach you related rates. Now, have you ever had a teacher that taught you a little too much?
Okay, so we're going to take this and this and this and this and obviously this. And, we have to simplify this, obviously. So if you plug this here and this here, and maybe we bring this down there, but we got to flip this around first, so we got to put the negative there to bring that all the way back.
Have you ever had a teacher that taught you too little?
All right, class, so we got this right here. Show you a little simple thing you can do. So take this there, and I got 70. So that's our answer to this. That's 70. All right, we're here to teach you some related rates. Okay. This is our equation, and from earlier sections we learned that you have to take the inside outside. So we're taking the derivative with respect to t, which is dt. So this is right now. This is our outside of it, because it's just square root 1/2 to the negative half. That's our inside stays the same. Then we're going to take our inside, which is 2x dy dt, because we're taking it in respect to time. Then we have dy, or 2y dy dt, because once again we're taking it with respect to time. A police cruiser is approaching a right-angled intersection from the north and is chasing a speeding car that has turned the corner and is now moving straight east. When the cruiser is 0.6 miles north of the intersection and the car is 0.8 miles east, the police determine with radar that the distance between them and the car is increasing at 20 miles an hour. If the cruiser is moving at 60 miles per hour at the instant of the measurement, what is the speed of the car? Okay, our problem from the board, this is our police cruiser, which is chasing our speeding away car right here. And the car has made a left turn and it's going straight east. And now the police cruiser is tracing that car. Now that we have drawn our triangle using the two placements of the car, we need to figure out the lengths of each of the sides, and we need to figure out the speed at which each car is going, which we can refer back to the original equation for.
We refer back to our original problem, and we found that y equals 0.6, x equals 0.8, and using a 3, 4, 5 triangle, s equals 1. The police car speed is 60 miles per hour, which is represented by negative 60 because it's going towards the intersection. The distance between the two cars is increasing at 20 miles per hour, and we're trying to find the speed of this. Okay, so we take our equation, which is Pythagorean theorem, because we're using a triangle, and you differentiate it. And 2x squared becomes 2x dx dt. Y squared becomes 2y dy dt. And s squared becomes 2s ds dt. You need to solve for dx dt. So you subtract 2y dy dt. So that equals 2s ds dt minus 2y dy dt. And then you divide by 2x. So dx dt equals 2s ds dt minus 2y dy dt divided by 2x. Next thing you need to do is plug everything in. So dx dt equals 2 times 1 times 20 minus 2 times 0.6 times negative 60 divided by 2 times 0.8. And once you solve, dx dt equals 70 miles per hour. And then you can interpret, and the car, the speeding car, was traveling at 70 miles per hour. And here's our second example. A hot air balloon rising straight up from a level field is tracked by a rangefinder 500 feet from the liftoff point. At the moment, the rangefinder's elevation angle is pi over 4, the angle increasing at a rate of 0.14 radians per minute. How fast is the balloon rising at that moment?
Okay, so we started with step 1, which was to draw a picture, and we saw from the film in the gym that the balloon was released, and when it reached the angle at pi over 4, that's when Luke took his reading from the gym, which created this triangle where our base is x equals 500 feet, and we're trying to find the height, rate at which it increased, which is dy dt.
So we wrote down all of our information, which is the second step. We figured out what we needed to find. And then we figured out that to find the rate, you need to use the tangent of y over 50, or y over 500, which turns into y equals 500 tangent of theta. Take the derivative, which turns into 500 ck squared theta times d theta over dt, because it's related to time. And then we plug all of our variables in, and you get dy dt equals 140, and then you interpret, so the balloon is rising at the rate of 140 feet per minute.